you have gyrometer, right? You have a GPS tracking module in the mobile phone. So all these sensors are able to collect data of your day-to-day activities, right? So now, and this data is being generated at random, I mean, at tremendous pace. Like if you see the amount of data that is generated, that is huge. Imagine just one person coming up with a lot of data, and then if there are a million people, the total amount of data that is generated from the million people is huge, right? So these two problems have been solved over the last 5 years with both advancements in terms of hardware and advancements in terms of data generation. So because of these sensors are associated with all these devices, so you see that these two problems are solved, and suddenly researchers across the globe have found data sets to work on and have found computing resources to run some meaningful algorithms. Okay, so what we're going to talk about today is a little more advanced steps. So how 5G is transforming all these things. Okay, so now we see that when this data is being transmitted, so this has to be transmitted somewhere to make some meaningful outcomes, right? So the entire data is now moved to cloud. So everyone is aware of what cloud is, right? Now no data stays with you. The entire data is actually stored on the cloud. Like for example, if you open Facebook, right? So when you open Facebook or your Gmail, none of those posts, none of the mails, none of the other documents that are associated with you are lying on your machine, right? All of these are actually on the cloud. So what is the benefit of having it on the cloud? So you don't have to be restricted to one single device. Let's say you have a document that is shared with you. You can see the document on your phone. You can see the document on your laptop. Probably if you go to college, you can log into any other machine and then see the same document, right? So that is a benefit of having the data at the cloud. But what is not good about the cloud, right? So you don't want all the data to be on the cloud. There could be some private data, your passwords, your credit card data, all these things. You don't want to have it on the cloud, right? So the cloud environment has both advantages and disadvantages. So we'll be looking at an alternative for that with the help of 5G. How is it benefiting the privacy issue? How is it solving the privacy issues? Okay. Okay. So like I said, intelligence is primarily associated with the cloud. So what do you mean? Okay, what do you mean by intelligence? So this is one interesting discussion that I had recently with one of my friend's parent. So he's a doctor, and I had to go to his home. We had a meetup, and then he asked me one question. So hey, so you're working on machine learning, right? How do you define artificial intelligence? Everyone is talking about artificial intelligence. So how do you define artificial intelligence? Uh, so then I couldn't come up with a proper answer that can actually satisfy the gentleman there, because he's around 60 years old and is a doctor. So how can I tell in simple terms to make him understand what artificial intelligence was? So my friend there was talking about, so you get some kind of data, you run some algorithms on it, and you do some kind of prediction and all those things. But he was not able to follow it because his profession is different. So then when you take a step back and then understand what is intelligence, right? When you say someone is intelligent, so intelligence is nothing but taking a decision, right? Intelligence is nothing but is taking a decision. Taking the right decision is what is intelligence, right? Now, how do you take a decision, or how do you take the right decision, right? So you take a decision based on the facts that are available with you. Okay, so you gather all the facts, and then you come to a conclusion whether the decision is right or wrong, right? How Like a simple example could be, you want to go from your place to your college, right? So would you take the longest route, or would you take the shortest route? So first thing you would be doing is you would prepare what all routes are possible, and then you'll see which route is shortest, and then you take a decision, right? So that is intelligence. Now if the same thing is being done by a machine, where the machine is given all the data, and then the machine is able to take the right decision. The right decision is also important. Not just taking a decision, but taking the right decision is important. So when the machine is able to take the right decision, then you will say that the machine is intelligent. Now, since it's a machine, you would say it is artificial intelligent, right? So if a machine is able to take the right decision based on the data that is given to it, then you would say that the machine is artificially intelligent, right? Okay, so when you come back to the current infrastructure, like what is happening today, the intelligence, like I said, is actually associated with the cloud, right? So if you want to have, so what is the other disadvantage of having intelligence in the cloud? The problem is of latency, right? What do you mean by latency? Latency is the delay. Like if I ask you a question and then you give me an answer of after 10 minutes or 15 minutes, or if your professor asks you a question and then you don't respond for 10 minutes or 15 minutes, it's not a good sign, right? So whenever someone asks you a question, you need to respond immediately. So that the delay is called latency. Now, why does latency play an important role? So there are some applications where you cannot avoid latency at all. A best example could be a smart car, right? So what is a smart car? Smart car or an autonomous car. So you don't have a driver in the car. You just sit in the car and then the car takes you wherever you want to go, right? Now, let's imagine a dog comes in between, right? When the car is going, a dog comes in between and the car is supposed to brake, right? So the amount of time taken to process that data and then see if it's a car, if it's a dog, and then whether it has to brake or not is latency. Now, if that latency increases, you'd probably hit the dog. Okay, no harm done because it's a dog. Now, what if it's a person, right? So if there is an increase in latency, you'd probably go and hit the person, right? So it becomes very important to understand scenarios where latency plays a major role, right? So there are use cases where you don't need applications. It's okay to have more latency, but there are applications where latency is of utmost importance, right? Okay, so how can you avoid it? How can you reduce the latency? You cannot reduce the distance between your device and the cloud, right? What is the other alternative of doing that? So the other alternative of doing that is to bring in another layer called the edge. So edge computing is again widely talked about in the industry today and in research. So everyone is talking about edge computing. So why should intelligence be coming to the edge, right? So edge is nothing but a layer between your device and the cloud. Like for example, let's say you host a cloud server on Amazon, right? So there's something called as AWS, Amazon Web Services, where you can host a web server. Now these servers are typically in US. So there's definitely a delay when you send some kind of data or some kind of request device to the cloud server, right? So to reduce this gap, what people have done is have actually set up a net server within India. Like for example, there could be an Amazon edge server sitting in Hyderabad, sitting in Mumbai, sitting in Chennai. So there could be these edge servers that are sitting on all these metros. And there's one cloud server sitting on the US. So what we have done is actually introduced another layer to reduce the latency when a request is made from the device, right? So what is the advantage of this edge server? Now, if you're following the news, government of India has come up with policy saying that all the data that is generated in India is supposed to be should not go out of India, right? So whatever data that is being generated in India should not go out of India so that people don't misuse it in different countries. Best example is your TikTok, right? So let's assume that TikTok is actually sharing or is actually gathering data from your device, right? So you don't even know if you're doing TikTok, then you will not even know what the device is gathering, what data is the device gathering, right? So it could probably gather your location, it could probably gather what is it that you're shopping, and it could probably gather your other personal information and then silently transmit that data to a server in China, right? Similarly with Facebook. So what happens is government comes up with this policy saying that whatever data that is generated on the devices in India should not leave India, right? So how can TikTok solve this problem? So the way it can solve this problem is to introduce servers in India, so data servers in India, so that the data doesn't leave the country, right? So that is one important that comes with this privacy, right? Similarly, it also solves the problem of security, and again, it solves this problem of data staying local to the country, right? Now, the other thing is personalization. So personalization, if you look at it from the country perspective, you can always generate content specific to India, right? At the same time, you can generate content specific to uh, language-based states. Like for example, you show more ads of Telugu to people from Andhra and Telangana, right? You could show ads in Kannada for Karnataka people. You could show ads in Tamil for Tamil Nadu people. So this kind of personalization can be done when these servers are situated uh, within a certain location, right? Like for example, if the server is within Andhra, then you can always say that any ads that you want to show for this server can always be translated to Telugu and then show, because most of the people speak Telugu here, right? So there is definitely a need to come from cloud to the edge, right? That is one thing. Okay, there's one more thing, why you need to come to edge and not on the cloud. Now, 6 7 years back, or maybe 10 years back, the household has to have is having only one telephone, right? So if you see 10 years back or maybe 15 years back, the entire house has only one telephone. Now, if there are 4 members in the family, all 4 members have a mobile phone with them, right? So if you see the communication load, it's actually quadrupled, like 4 times increase, right? Now imagine if there are 1,000 families in your 100 families in your locality, the number of devices has increased to 400, from 100 to 400. So this actually brings a lot of load on the cloud server. So it's possible that the cloud server may not be have is not able to handle such kind of load, right? So to reduce the load also, it becomes important for us to bring all those computations to the edge devices, right? Okay. Okay. So what happens when you bring all these computations to the edge device, right? So in 5G, so all of you are familiar with what is 5G, right? So now everyone can actually transmit and receive data at high pace, right? So that is a benefit of 5G. Now, when this kind of interface or this kind of network is possible with the devices, the edge computation plays a very crucial role, right? So now, like I said, the crucial things that are needed for edge cloud are low latency, right? Like, ultra low latency. So this is very important for an edge device or edge network, right? The second thing is analytics and opportunity to provide tailored value. So tailored value is nothing but personalization, right? So I'll just stop for a brief moment and then take some questions if you're following what I'm saying or if I'm too fast in speaking. So just message me if you think there's something wrong. Otherwise, I'll continue. I'll just take a minute and then we can just continue. Okay, so I would assume that you are following whatever I'm talking so far. So let's just continue.
Continue, sir.
Yeah. Okay. Okay. So we have understood the benefit, or we have understood the need for having this edge server, right? Okay. Now, need is one thing. Now, what is the amount of money that is involved? So why do you, so what is the amount of money involved in having this kind of infrastructure, right? So with 5G, you're actually coming up with a $5 trillion market. So this amount of market is present to grab, like in different areas. So for example, as shown in the slide here, manufacturing alone has close to 3.3 billion dollars of market, right? So similarly, transport and construction, utilities, and then mining. So transport and manufacturing is, the market is huge, right? So how, if you take an example for it, uh, most of the startups, even in India, so there are a lot of startups that are coming in India where we are using this 5G technology or the internet to ease the transportation. Things which have not been even imagined, like even those which you could not able to imagine, are being done today in terms of transport. Best example is your autonomous cars, right? So everyone knows about this company called Tesla, which is actually into manufacturing electric cars, right? Now these electric cars have an autopilot mode, right, where you don't need to drive the car at all, and people have been using it widely in the US. So though it has not come to India, so if you look at videos on YouTube regarding the cars manufactured by Tesla, uh, most of the cars are capable of running autonomously, right? So when you say autonomously, you don't need the driver to be behind the wheel. So the car knows which road to take because it's already linked with maps. So it knows you just have to give it the destination, and then the car is able to go to that particular location. So it knows how to stop, it knows how to check for a signal, it gives an indication when it is changing lanes, and all those things is actually in production, right? People have started using it. It is not that it is still in research or infant stage. People have started using it, and recently Tesla says that it is almost able to reach full autonomous state. Now any user who's buying, any customer who's buying a Tesla, so there is a statement where Tesla says the driver needs to be behind the wheel. So you cannot leave the car alone for the current Teslas. But now recently Tesla has said that it has upgraded its technology where you don't need to be behind the wheel, right? So how is this possible? Now, if you imagine the amount of computation that is required to do all these things, right? To sense, to move, so all and then to take a decision when something comes in between. When you see a red light, you have to stop. When you see a green light, you have to go. So all these decisions have to be taken instantaneously, right? So things have been moving very quickly. Now, actually, a company called Uber has also come up with something called as Uber drones, right? So drones, so that is also autonomous vehicles where you can actually book a drone where you can go get into the drone and then drone takes you a place. So this is already being tested in countries like Dubai and China, right? So all these devices, right? So to make decisions, need to transfer a large amount of data, and the decisions have to be taken at a very within a very small time, right? So once this technology came in, the 5G technology has come into picture, the opportunities or the applications that are revolving around the 5G have exploded, right? In on all these different manufacturing and other categories. Okay, so if you look at the roadmap, so how industry is evolved. So currently we are living in a age where you have 4.0 plus 5G. So this is nothing but what I've been telling earlier. So you have the internet facility where you can download like tons of data within a fraction of a second, right? So the current technology is Industry 4.0 plus 5G. So what is the benefit of this? So we are actually having connected devices, right? For example, smart homes, smart watches, uh, and uh, and all other IoT devices around you, and you're able to take some meaningful decision using the data that is being generated by these devices, right? Okay, so let's just so since we are halfway into uh, the session, the next half of the session, I'll take a small example so that it's more clear how company like Google is using these technologies to make some meaningful applications. Okay. Okay. So let's just. Okay. So what we have learned so far is we know that 5G has enabled people with transmitting lots of data, download lots of data, and there is hardware that is able to do it. Now, what we will talk about is one of the recent applications that has been introduced with Google on how you can use or leverage this data and then come up with some uh, machine learning mode. So I think everyone is familiar with what machine learning is. So I will not uh, delve too much into the details of machine learning, but I'll give you simple example of how or what is done using this approach. Okay, so this approach is called federated learning. Okay, so simple example on what Google has done is something called as a next word prediction, right? So everyone chats on WhatsApp, right? So when you type something, you would see some kind of uh, predictions that come on the top. So there are 3 words or 4 words that come. When you say th, it'll probably say that or then, right? So there's some kind of prediction that comes, and then you can directly use that word and then continue with your typing, right? So similarly, if you observe in Gmail, by default, when you type something, it will complete the sentence. So this feature was not there before. So recently, if you just type be at the end, so it will automatically fill it for you saying best regards or something like that, right? So you would have noticed in Gmail. So people who've used Gmail for last 5 years or 6 years would see the difference now. So what Google has done is coming up with something called as a next word prediction on your Google keyboard, right? So what is your Google keyboard? So when you open your WhatsApp and then you type the text box, a keyboard comes onto your phone. So whenever you start typing something, you will get some kind of predictions as to what the next word could be, right? So we'll talk about that example. So what is this federated learning all about, right? So we talked about privacy, we talked about data. If data leaves the device, then it's very sensitive. So there will be some privacy issues and all those things. So what Google has done is, can we run some kind of machine learning algorithm on the device and make sure that the data doesn't leave the device, right? So without the device not leaving, without the data not leaving the device, can we make some, can we form a global model, right? Like for example, let's say you're in a classroom, okay? So everyone types what is, okay? So 50% of the class types what is your name, or let's say 25% types what is your name, 25% types what is your rank, 25% types what is your age, and 25% types what is your address, right? So if you keep typing what is your name continuously, so what your machine learning algorithm will tell you is, whenever you type what is, it will always give you a suggestion of your name. Because you've been typing what is your name very frequently, you will say whenever you type what is in your keypad, Google will give you with an option or on the top saying that your name. So it'll try to give you some kind of suggestion. So the suggestion that will be your name, because you've used this your name more your name as most frequently used word, right? Now Similarly, someone who's typed what is your age more frequently would see your age whenever he or she types what is in the text box, right? Now, if you have to learn a global model from all these people, like if you want to see all these four sessions as name, age, rank, address, if I want to see all these suggestions given by different people in my class, how will I achieve that, right? So the way in which I can achieve that is collecting all this data from all the students and then build a machine learning model there. And then whatever model I get, I send it back to all the clients, right? If, for example, like I said, 25% of the students will have to transmit the entire data to a server, a central server. Similarly, the remaining 25% have to send their data to a server. The third portion also have to send, and the fourth portion also have to send their data to a server. Now, if you see, this is the same problem that we've talked about earlier, where you're sending the data to a central server, right? What is the issue with that? Privacy. Right? In this case, it is just simple text words. But what if it's healthcare data or some other private data, right? So people would not want to transmit all this data, right? So you see the problem of privacy in this case, right? But what is the goal? I want to achieve it, right? When I type in what is your in my keyboard, I have to see all these four options. The four options are I have to see name, I have to see age, I have to see rank, and then I have to see address. I have to see all these four suggestions on my keyboard. But how can I achieve this kind of solution without transmitting data? When you say, oh, you can't transmit data because it's privacy issue, but then you still want all these suggestions to be seen. So how can you solve this problem, right? So to solve this problem, Google has come up with this new idea called as federated learning. Okay, so what it does is it's actually enabling the machine learning engineers to come up with models on decentralized data. So you see that the data is decentralized in our application that I gave. The data is actually decentralized between different people. So all the 100 students, the data is with all the 100 students. So who is generating this data? So this data is being generated by the students themselves, right? So you keep typing what is your name again and again. So you're actually generating data, correct? Okay. Now, so we've discussed why do we need federated learning, right? One reason is definitely privacy. What is the other reason? So let's say you generate 1 GB data at every 15 minutes, or maybe 512 MB of data every 15 minutes, right? So at the end of 1 hour, you're generating about 2 GB of data. So this 2 GB of data need to be transmitted to a central server, right? So privacy is one issue, but the other major issue is you're using up a lot of bandwidth. Now imagine one user sending 2 GB of data to a server, and then 100 students also sending 2 GB of data to the server, right? So you're actually eating up all the bandwidth, right? So these are the two problems that we have to solve. Okay. Now, this is the same example that we were talking about. So we talked about only a mobile phone. Imagine the same situation to be in car, right? Like for example, you know how Google Maps work, right? So Google doesn't monitor any of the traffic data, right? So all it does is since your location is on, so you would see that whenever you want to use Google Maps, it will always ask you to enable locations. So if your location is on, then it keeps transmitting your location data at regular intervals. Now, if the server sees that your movement is restricted, you're traveling and then your movement is restricted on the road, then it will immediately update its data, says that okay, there's some kind of traffic jam here, right? It doesn't do it just based on one device. So if there are multiple devices in closer proximity, so you will also understand that when two devices are close to each other, you can actually measure the distance between them. And then what Google does is it will see the proximity of these devices. And then if there are a large amount of devices like that in one particular location, then it will probably mark that particular location in red on Google Maps, indicating that there's some kind of traffic jam on that particular road, right? So Google doesn't take any satellite pictures, or doesn't It did not actually install any sensors and all those things. So it knows that majority of the people use Android phones and their location services are on. So it uses its location data. So you are constantly sending your location data to Google, and Google is actually using that data to monitor the traffic, right? So if you want to see all that, so there is an option where you can see the location data. So if you go back to your Google settings and then see the location data, you can actually see where you have been over last 1 year or 2 years or 3 years. So you can basically see where all places you have visited, right? So you can imagine the privacy issue. So Google knows where you have moved. So that is the problem with privacy and all those things. So Google actually tracks every device, and then you can see where you're going. Okay, so that is the example of Google Maps. Now there are other devices that are now getting connected to the internet. Like for example, Amazon Echo, so Nest. So you know what Amazon Echo is, right? So Amazon Echo is a small device that can read or that can listen to your commands and then place orders on Amazon and things like that. Okay. So all these devices are now connected to the internet and then actually are generating large amounts of data, and then you want to make some meaningful predictions out of it, right? Again, so we discussed all these points as to how data works, and then how data can be used on the edge to make faster decisions. Okay, so if you look at 2014, right? So that is like at least 5 to 6 years back. What people used to do if they want to get some meaningful information is to get the data and then log it in a central server, right? So, or if you don't want to use it, then what you do, you don't use the data and then don't improve the product and services, right? So what is the other alternative? Come up with a new solution. So what is the best way? Best way is to come up with new solutions. So the team at Google came up with this approach called federated learning. Okay, so we'll see what federated learning is. Again, this is a sample example where you have data on the cloud and then you use that data to come up with some kind of analysis, right? Okay, so now you have more number of clients, large amount of data being transmitted. So once you have the data, the server gives you a machine learning model, and this machine learning is actually deployed on the devices. Okay, now, so what Google has come up with is, instead of sending the data to the server, let's just build a machine learning model on the device itself, right? So since you're aware that most of the devices are very powerful, they can run some kind of low-end machine learning algorithm on its device. So what these clients do is they build this machine learning model on the device itself. Okay, and instead of transmitting the data to the server, they send the model parameters to the server, right? So what do you mean by these model parameters? Like for example, I'll give you a simple example not related to machine learning. So you know that if you have data, like in yesterday's session and day before yesterday's session, we've seen that every data follows some kind of distribution, right? So instead of sending the actual data, what if you find out what kind of distribution the data follows and then just send the distribution parameters to the server, right? So for example, if a distribution is following normal distribution, you can find out what is its variance and what is its standard deviation. You compute the standard deviation and the variance and then transmit it to the server, right? So that is the parameters of this distribution. Similarly, a machine learning model has its model parameters. So the clients compute machine learning model on the device. They don't transmit the data, but they just transmit the parameters. Similarly, all the clients don't transmit the data, but they just transmit the model parameters to the server. What the server does is it will average all these weights and then transmits back the averaged model to the clients. Like for example, we talked about the prediction, right? Google keyboard prediction, where every client, so imagine each each client builds a model on the device itself, right? So for example, I'm building a model that predicts what is your name. Okay, so I've built the model. So instead of sending all the data that I have, I'll send only the machine learning parameters or the model parameters that I have come up with to the server. Similarly, other people will send their own model parameters to the server. So what the server does is it will average all these model parameters and then transmit back the averaged model parameters. It is very surprising that once you have this averaged model weights, your client is able to predict all the other three options. Like for example, the moment when I type, once this process is done, the moment when I type what is your, earlier I used to see only name. Now I will see four different options. That is what is your name, age, address, and rank. Okay, so in this slide, you can see that the data is generated on the device. The machine learning model is built on the device. Okay, and only the model parameters are transmitted to the server. So did we solve the two problems that we were talking about over the last 30 minutes as to what is happening? How do we solve this problem of privacy? How do we solve the problem of network bandwidth? Now you see that instead of transmitting the entire data, we are transmitting only the model parameters. So what could be the size of model parameters? A few KB or probably even less, right? So you transmit such less amount of data instead of the entire data, right? So you've solved the communication problem. We've also solved the privacy problem, right? So now the data is not leaving the device, right? At the same time, you're able to get the required outcomes where you're able to get suggestions from the uh, other users, right? Okay, so if you see the figure now, so this model building is done by every device. Okay, and once all these models are accumulated at the server combines this model. Okay, and then the combined model is transmitted back to the device. Now another thing is, it is always possible that the engineer, or as you see on the slide, the engineer at the server can also be malicious, right? So he may be able to see the data, right? So now in this case, he'll be seeing only the model parameters. So seeing the model parameters, he will not be able to come up with any meaningful information. Okay, so what is the benefit of this? So even if the number of devices increase, even if the number of devices increase, you would see that the amount of load on the server is also very less. Why is that? Because all the server is doing is just averaging all these weights to send it back to server. It is not doing any complex machine learning computations on the server. So you can this approach is also okay. So again, let me just take 2 minutes break to take any quick questions that you have. If you have not understood what federated learning is, probably I'll just repeat what I've said. Or if you want to know some more applications of where federated learning is used. Any doubts so far? Okay, fine. So I would assume that okay, so why the reason why we're talking about federated learning is over the last 4 years or 3 years, every university, every top university have been doing some kind of research on this federated learning, because this was supposed to be a game changer for most of the machine learning problems associated with cloud computing. Meaning, if you saw the previous slide where we were talking about data being transmitted in 2014 to a central server, now you don't have to transmit data, and at the same time you're able to achieve similar accuracies when compared to that of a centralized setup, right? So what is most important, what is the most important thing about a federated learning system is the scalability. So even if you have millions of devices, this setup can actually accommodate that amount of data, that amount of devices. So you see that there's a large explosion of devices, and it becomes very difficult to handle when you transmit all this data to a server. So to avoid all that, this approach is proving to be a game changer in the current applications. Okay. Okay. So someone can ask, so is this approach foolproof? Like, does this solve all the problems, or does it have any problems of its own? Right. Uh, so that is something that researchers are working on. So there are some issues that are associated with federated learning also. Like for example, any data can be divided into two different parts: IID and non-IID. So, like for example, you know that every data is a labeled data. Like for example, uh, if you talk about cancer data, if you take a data set which has data related to patient's health records, and you're supposed to predict whether the patient has cancer or he doesn't have cancer, right? So any data which has a label like a yes or no or a classification is called or the learning is called supervised learning, right? So when the data is partitioned based on these labels, like for example, one client gives you data only related to patients having no cancer, and one client is able to give data related to only cancer, right? So if you have to come up with a model that can predict both yes or no. Okay, another example is the same thing that I talked earlier, where uh, one group of students is one group of students is giving you only one prediction, that is what is your name is the only prediction which one group of students is giving. One group of students is giving you only one prediction, that is what is your rank, and one group is giving you what is your address, right? Now when you have to combine all these three things, everyone should be able to, when a new sentence comes in, when someone types in what is your, any device irrespective of that group should be able to see all these three options, right? So it has to see name, rank, and address. So initially, when you were building model, you would see only one prediction. Now, after building the model, after building the global model, you will see all the three predictions. So when the data is partitioned in such a way that one group gives only one label, such as name, and one group gives you only one label called rank, and one group gives you only one label called address, that is called non-IID, right? But when you have mixed data, it's called IID. Right? So how does federated learning uh, work with scenarios where you have both IID and non-IID data, right? The other problems are network related problems. Now we saw that the server needs to average all these weights, all these models have to be averaged to the server. Now you can't assume that all these models come to the server at the same time. So what if one client sends model at t equal to 0, and then the next client sends it at t plus 5 or t plus 10, right? So the server has to wait. So how long should the server wait, right? So that is something that you have to work on, because it's asynchronous in nature. The networks are asynchronous in nature, right? So how long should the server wait until it averages all, until it gets all the data from the clients, right? The other thing is, how many clients should it consider? How many clients should it consider for averaging it? Now, what the other thing is, what if the clients themselves are malicious? What if the clients are wantedly sending wrong data? So how is the server able to identify which client is malicious and which client is not malicious, right? So security related aspects, and then network related aspects, all these are different problems that are associated with federated learning, and people have started working on this extensively over the last couple of years. Okay, so this is just the algorithm. The first algorithm that was introduced. It was introduced in 2017. So 2017 is just 2 years, 2.5 years old, or 3 years old, and like I said, it has gained a lot of traction amongst researchers. So if you see, what this algorithm does is, the first step is, instead of selecting all the clients, the server selects only a subset of clients. Okay, and all these clients send the parameters theta. So theta is nothing but the model parameters when a machine learning model is built on the client. Okay, so once the server receives theta, it will average all these weights and then send back the weights to the client. A very simple algorithm, but it's actually doing wonders. Okay, again, different approaches that have been done. Okay, another interesting exploration was, now if you have to average all these weights, right? If you have to average all these weights from different devices, it is important that all these devices run the same algorithms. It has to run the same algorithm, because if you have to average the weights across these devices, now people have started working on what happens if you run different kind of machine learning algorithms on different devices. Can we still follow this kind of approach? Or if we are not able to follow this approach, what is the kind of approach that we have to follow so that we achieve similar results? Right? So that is again an interesting area we have started looking into. So this algorithm has been run on different data sets. The first data set was used on next word prediction. So Google had this luxury of having all this data for the sentences that are typed onto the keyboard. So they've used that data to come up with a next word prediction data set. Okay, so they've run it on other data sets also, which have given some interesting results. Okay. Okay. So this is the same example that I was talking about on the keyboard. Okay. So the keyboard given by Google is called Gboard, like Google board. So you type something, and then you have to predict the next word based on the type text so far. Okay. So again, reiterating, when should you consider federated learning? When you have more data. So this is also important. So can we always use federated learning, or are there some kind of restrictions when you use federated learning? So the first thing is, when you have a lot of data on the device. So if you don't have data, then it doesn't make sense to build a machine learning on that model, right? So machine learning model gives you good prediction only if you have large amount of data. So if your local device or if your phone is not generating more data, then federated learning doesn't make any sense. Okay. Uh, the other one, privacy sensitive, right? So if the data is sensitive, like health data and other data, which you don't want to transmit to a central server, then federated learning can definitely be used in such scenarios. Okay. Okay. So this is again an improvement of their initial approach. So they've used RNN, recurrent neural networks, and they've using RNNs, they've actually increased their net store prediction by 24%. Okay. So what is the other interesting things that they have been doing? Emoji prediction. So emojis are now widely used, right? Now you have a lot of GIF images and all those things. Now, can you do an emoji prediction? Like, for example, if you understand the context, of the conversation, can you predict the emoji? Like, if the system, if the device is able to understand that you're in a good mood, okay, so the moment you open the keyboard, can it automatically give you a suggestion for a smiley or a laugh or a ruffle or a lol? So can it give a suggestion for the emoji? So that's pretty interesting, right? So it is able to understand what kind of conversation you're doing with your friend and then automatically give suggestions for the emojis, right? So that's something very, very interesting that people have been working on. Again, uh, suggesting a GIF, suggesting a sticker, or suggesting a search query. That is the action. That is also again very interesting, interesting application where when you open the keyboard, if the keyboard again understanding the kind of conversation that is being done and understanding the way in which you are able to understand the way in which you like to do. Like for example, uh, let's say I use only emojis, right? I use very less text and then I use a lot of emojis. So the device understands that okay, this guy uses a lot of emojis, so let's suggest him in emoji instead of a keyboard, right? Or probably if I use a lot of stickers, then probably it will suggest me stickers, the right stickers, instead of a GIF or a smiley or a text, right? So based on my previous actions, based on my previous usage, the machine learning model on the device is able to give some kind of relevant prediction, right? Okay, so I think we've reached. So this is what I want to convey. So far, I think we've reached the end of the our session. So just to recap what we've done, we've seen what IoT and 5G can do. So what it can do is bring in tremendous amount of data into the system, and you need applications that can be built on these devices, as well as on the servers. So to avoid bombarding cloud with such large amount of requests and data, we saw the evolution of an edge server, which can take the load from the cloud. We've also seen how, since the devices themselves are becoming more powerful, how can you further reduce the load on the edge servers and the cloud by bringing the computation onto the devices, right? So we've seen an example of federated learning introduced by Google, and we've seen an example where using federated learning, how can you actually come up with next word prediction, emoji prediction, and then some kind of action prediction when you're typing something. So this is just one example, but it has a lot of other applications also. So we've seen how the computation has moved from cloud to edge to device, and how you're able to bring out some meaningful benefits to the customer or benefits to the end user. Okay, so I think that's the end of my talk for today. So if you have any questions or queries, do let me know. Message me so that if you want something to be taken up tomorrow, I'll probably work on that. Like for example, if I'm talking too fast, just let me know so that I'll slow down. If you want more time for questions, let me know so that I can take questions up front and then answer those questions.
Dr. Anirudh?
Yeah.
I have a question. It's
Yes, sir.
regarding the smart city.
Mhm.
As you may be aware that smart cities are going to come up at Vijayawada and all those places.
Mhm.
So the servers and devices means a lot of servers need to be deployed, or what will be the methodology through which the smart cities will come up? If you could consider this one for the tomorrow session, We just wanted to know something about the smart cities, how those things are going to work out in future.
Okay, I'll definitely stress more about that tomorrow, but I'll just give you an idea of a smart city in today's context, like what is happening. So you said they're coming up in Vijayawada soon, but if you see the news, Hyderabad's traffic police have come up with smart sensors and then all those things. They've set up some 200 smart devices at the traffic signals, right? So that at the control room they're able to get real-time traffic analysis. So they can do real-time traffic analysis on the roads in Hyderabad, right? Like for example, most of the traffic lights are based on some fixed times, right? So for example, a red light is there for 15 seconds, and then a green light is there for 20 seconds, and so on. So now what you can do is with these sensors, the traffic light can take a decision on its own, seeing if there is no traffic, then probably reduce the red light. If there is more traffic, increase the amount in red light and all those things. So you don't need manual intervention uh, to see and then take decision as to how long the traffic light should be there and so on. Okay, so this is just one example where traffic system is becoming smart, right? So I will stress more about smart cities tomorrow, definitely. Any other queries? Okay, I think if you have no more queries, I think we'll meet tomorrow.
Thank you.
Okay, sir. Thank you.